Problems come in all shapes and sizes. In the same way, our solution strategies need to be flexible to match the need. We need to escalate from simple, low-effort solution processes to more powerful processes when the risk and complexity justifies the effort. Cause tree analysis of the various possible causes and the way they interact is justified for high-risk, complex issues. 5 whys is appropriate for less important, simpler problems. But most of the time, probably more than 98% of the time, we solve problems with intuition. Intuition is fast, but is prone to error. We can understand how to improve the reliability and effectiveness of intuition by developing a model of how we solve routine problems. Our senses allow us to perceive something about the problem. We associate the perceived information with memories, normally subconsciously and within a fraction of a second. We apply a bias to filter unimportant memories out and select the one that is most pertinent, which then helps us form a conclusion that we act on. This process works most of the time because we tend to run into problems that we have somehow experienced in the past. But sometimes we'll be wrong because our perceptions are inadequate, our memories incomplete, or we associate with the wrong memory, or we apply the incorrect bias. We can improve our performance by referring to a list. The following example will help to show how this works. Say we are working in a factory and there is a forklift accident. Intuition would lead many people looking at this scene to think that perhaps the load was too heavy and that it was probably an operator error. The observation operator error has some value but does not tell the whole story. Very often people struggle to provide more detail. Picking from a list tends to help a person remember more possibilities that they can make an association with. A person investigating an incident might be tempted to add operator error as a cause after load too heavy. They would get a better result by clicking on add human factor instead. The investigator is asked to select from a carefully devised list of alternatives. Each selection leads to a unique list that the investigator can choose from. This hierarchy of human factors was inspired by specialists at the US Federal Aviation Administration who looked at human factors contributing to aviation accidents. The words and concepts have been modified to match accidents in workplaces where people operate equipment. This approach engages the investigator's own memories and associations with those of specialists who have had the time to think through all of the possibilities. All investigators make selections from the same validated lists. This opens up the opportunity to use statistics and graphs to show which causes are most common and what sorts of systemic issues need to be addressed. The use of structured cause analysis hierarchies, or SCARs, significantly improves the results based on an investigator's intuition. Of course, best results will be achieved when the SCAR has been customised to match the particular workplace. Ishikawa or fishbone diagrams are a very useful way of visualising and editing SCARs. The hierarchy used in the previous example is shown on an Ishikawa diagram. It is best to engage a team of people familiar with the ways that problems occur in the particular workplace to edit and improve the ideas on the diagram. The previous example showed how a structured cause analysis hierarchy, or SCAR, can be used as part of an investigation. SCARs can also be used very effectively at the time when issues are first reported to assist with categorising and understanding issues. The screen shows a typical issue reporting system with a SCAR embedded under a particular field. Again, this very fast and easy process delivers choices off validated lists, so statistics and simple graphs can be used to show trends and help prioritise actions. Many will use intuition as a first pass way to categorise issues, accepting that in many cases the selections will not always yield accurate problem solving. Before finishing any discussion on problem solving, we need to remember the key to success in problem solving is the rigour to test our assumptions, theories and causes against real evidence. Returning to our example, our intuition told us the load was too heavy, but in fact there may have been other causes. Perhaps the load may have shifted, perhaps the strap holding the load in position broke. We need to gather evidence to prove our assumptions. In this case, we need to establish the weight of the fork was lifting. So, if it is important to be right and time permits, then always remember to seek evidence and escalate to stronger problem solving processes like 5 whys or the 12 steps and cause tree if justified. Every option has both strengths and weaknesses. The strength of our natural intuition is that it's fast and inexpensive. The weakness is that we are prone to error. This is aggravated by the fact that we tend to find it hard to discard beliefs once they are formed. Lists that have been created by experts with time to think through the various options help to improve accuracy. If everyone picks from the same lists, then statistics and graphs can show trends, but lack of accuracy is still the main weakness. Finally, in summary, the rigour and resources applied to problem solving should be matched with the risk to the organisation and the complexity of the problem. The 12-step cause tree process for the few high risk and complex issues. 5 whys for the many medium risk, relatively straightforward problems. Intuition for the vast majority of routine issues. Intuition depends on the mind associating perceptions with memories, applying a bias and jumping to a conclusion. This process can be improved by using lists. Collaboration using Ishikawa diagrams is a powerful way to develop a SCAR. I'm Bill Holmes, and I hope you've enjoyed watching this video and that you'll come back soon and see videos on how to assess risk and use appropriate approaches to solving problems.